My name is Marianne Meyerson, and I am a third-year chemistry major from the class of 2019. Today we will be working through Chapter 3.1, Problem 8, letters A, B, and C in the General Chemistry Workbook. You should begin by working on the problem yourself to see if you can get the answer. Pause the video now until you have completed the problem. Then we'll go over it together. So problem A gives us the compound ibuprofen. It also gives us the percents of the three different elements that make up ibuprofen. So it has 75.69% carbon, 15.51% oxygen, and 8.80% hydrogen. All of these percents add up to 100%. So from here, we can convert these percents into grams, assuming that we have 100 grams of ibuprofen. We have 75.69 grams of carbon, 15.51 grams of oxygen, and 8.80 grams of hydrogen. Now we want to convert the grams into moles so that we can compare the molar amounts of each element. To do this, we use the molar masses from the periodic table. So we multiply by 1 mole over 12.01 grams of carbon. Our grams will cancel, and we get 6.25 moles. We do the same for oxygen here. 1 mole over 16.00 grams of oxygen, and we get 0.969 moles. Lastly, we do this for hydrogen. 1 mole over 1.01 grams of hydrogen, giving us 8.73 moles of hydrogen. Now that we have the number of moles of each compound, we want to divide each by the least number of moles to get the simplest ratio or empirical formula. So the compound that has the least number of moles is oxygen right here with 0.969. So what we're going to do is divide each element by 0.969. So to do that, 0.969 gives us 6.45. Divide 0.969 by 0.969. That gives us 1. And when we divide 8.73 by 0.969, we get 9.01. So now we have our empirical formula, and that is C 6.45, O 1, and H 9.01. Now we're not done yet because carbon has 6.45 moles of carbon in the compound, and we can't really have 6.5 moles of something. So to fix this, we multiply the entire empirical formula by 2. Now we have C13, because we approximate 6.45 is about 6.5. We can do that approximation. Now we multiply oxygen by 2, so O2, and H by 18. So this is our final molecular formula for ibuprofen.
Hello, my name is Ray Takahashi, and I'm a third-year biochemistry major, and I will be doing part B of problem number 8. So part B is tetraethyl lead, so we will be doing the same thing as Marianne showed for part A. So we are given carbon, 29.71%, Pb, which is lead, 64.06%, then hydrogen, 6.23%. Now, because all these percents add up to 100%, we can think of it as 100 grams, and then since all these percents are now grams, we will convert those to moles. So for carbon, 29.71% 0.71 grams times 12.01 grams of carbon for 1 mole. Carbon, grams cancel out, and then we get 2.47 moles of carbon. And then PB, 64.06 grams times 207.2 grams PB for 1 mole. Grams again cancel, and then we get 0.309 moles of PB. If you could find the molecular weight of PB, it's number 82 on your periodic table. And then finally, hydrogen. We have 6.23 grams of hydrogen times 1.01 grams hydrogen for 1 mole. Hydrogen, grams cancel, then we get 6.18 moles of hydrogen. Now zoom out a little bit. Ooh. And now looking at these, we notice that PB has the smallest amount of moles, so we will divide each of carbon and hydrogen by 0.309. So let's divide these by 0.309 to get 7.99, which is about 8. Divide 0.309 by 0.309, which gets you 1. And then for the last one, we will get 20. Now if you notice for this one, all of these are whole numbers, so you can write out the empirical formula for tetraethyl lead, which is C8PbH20, and that is your answer. And then for part C, you follow the same steps as part A and part B, and you can pause the video right here if you want to work it out, and your answer, you will get SiCrO4.